So what is the mechanism of digoxin? We know that cardiomyocytes, they getting calcium from outside, from outside as a major source of calcium, and we have a specific pump. It is a sodium calcium exchanger. Sodium calcium exchanger. So what does this sodium calcium exchanger make in cardiomyocytes? It pumps calcium outside instead of pumping sodium inside. Digoxin blocks sodium potassium ATPase. Sodium potassium ATPase. Sodium potassium ATPase pumps 3 sodium outside and 2 potassium inside. As digoxin blocks this sodium potassium ATPase, we have accumulation of sodium ions inside the cell. Why we have accumulation of sodium ions? Because after every action potential, a lot of sodium coming inside. So these sodium ions, they present in the outer surface of the membrane, and this significantly affects ability of this sodium calcium exchanger to pump calcium ions, as it's much more difficult to put more sodium inside the cell, and even present evidences that we have reversing action of this sodium calcium exchanger, and this sodium calcium exchanger start and pump sodium outside and calcium inside. As a result of that, we have rising in calcium level inside the cell, and this is important as increased amount of calcium causes increasing in contractility. Another interesting moment that we have sarcoplasmic reticulum also in the cardiomyocytes, and we know that sarcoplasmic reticulum is a storage of calcium, right? And in the sarcoplasmic reticulum we have sarcopump. Activation of this pump or stimulation of this pump increases amount of calcium stored inside sarcoplasmic reticulum, and during next contraction, more calcium coming from sarcoplasmic reticulum and also increases contractility. But let's talk about digoxin and about effects. Digoxin produces positive inotropic effect. Why positive inotropic effect? Because digoxin increases contractility, it increases force of contraction. Force of contraction. Second one, digoxin produces negative chronotropic effect. Why digoxin produces negative chronotropic effect? Why digoxin decreases heart rate? Because in response to increased force of contraction, with help of baroreceptor reflex mechanism, we have increasing in nervous vagus tone, and we have decreasing in heart rate. This is the one way how it's possible. And second way, digoxin produces vagomimetic action. It increases nervous vagus tone. Now I'll tell you how this is possible. You know that nervous vagus releases acetylcholine, right? And as all excitable tissues, it also has sodium potassium pump. Digoxin blocks this sodium potassium pump, not only in cardiomyocyte but in other tissues also. And blockade of sodium potassium pump in case of nerve terminals increases resting membrane potential. So let's say it becomes more positive. It causes a kind of depolarization. So resting membrane potential becomes more positive, and it becomes much more easier to reach threshold level. So in case of digoxin, as it's much more easier to reach threshold level, nervous vagus releases more acetylcholine molecules, and more acetylcholine molecules interact with M2 receptors in the sinoatrial and AV node, and this causes negative chronotropic effect. Also, activation of these M2 receptors in the AV node causes negative dromotropic effect. Negative dromotropic effect, as it decreases speed of conduction in AV node, and produces positive batmotropic effect. Positive batmotropic effect, it increases myocardial excitability. Increases myocardial excitability. Why? By the same mechanism. Yeah, by shifting resting membrane potential to more positive level.